All right, this is lesson 83. I'm going to review exponents because now we're going to end up with exponents that are binomials. All right, so the first rule for exponents. If I have x squared times x to the fifth, the rule for exponents says I add them. Variable times a variable, both raised to an exponent, I add the exponents. So this is x2 plus 5, which is x to the 7th. Okay? So if you have, they're multiplied by each other, then you add your exponents. All right? Don't forget that rule. All right? Second one. If I have x squared over x to the fifth, when I move x to the fifth to the numerator, it becomes a negative 5. So effectively, I am subtracting the exponents. It would be 2 minus 5, right? Because this would become a negative 5 in the numerator, and then I would add them. So that would be x2 to the minus 5, which is x to the negative third. All right. A third rule says if I have x squared to the fifth power, an exponent raised to another exponent, I would multiply the exponents. So that would be x2 times 5, which is x to the 10th. Now we're not going to have values for our exponents. We're going to have variables. Okay, so in this case, in the first case, if I had XA, XB, rules say I add them. So it would be XA plus B. In the second case, if I had XA over XB, when I moved XB to the numerator, it would be negative. So that would be XA minus B. In the third case, if I had XA raised to the B, I would multiply, it would be XAB. All right? And I think it will be clearer once we work some of these problems, how to do it. We'll work one of each 3 of these types of problems. So look with me on page 343 at problem 83-1. 83-1, page 343. And it says to simplify this, x to the a, y to the 2x, x to the a over 2, y to the 3x over 4. I look at my like terms, that being x, and because they're multiplied, it falls under our first exponent rule that I just covered, and I add the exponents. So that's xa plus a over 2. And then I look at my other like term, which is my y, and I add their exponents. It's 2x plus 3x over 4. In order to combine those exponents, I need a common denominator. All right, so the common denominator for a plus a over 2 is 2. So I multiply the first a by 2 over 2. And I end up with x 2a over 2 plus a over 2. For y, to find a common denominator, it's 4. So I multiply by 4 over 4, the first term, and I have 8x over 4 plus 3x over 4. Now I can combine my numerators, my exponents, all right? So 2a plus a, that's 3a over 2, and I cannot reduce that anymore. And y is 8x plus 3x is 11x over 4, and this would be my simplification, my solution, okay? Now let's look at 83.2. All right, and 83.2 it says to simplify x to the a minus 2, y a plus 4, and in the denominator we have x. We have x a over 2, y 2a. So when I move both of these to the numerator, these become negative. All right, so I'll write it's x a minus 2, x negative a over 2. Okay? And this is y a plus 4, y negative 2a. Now I can combine the exponents of my like terms by adding them. So this would be x a minus 2 minus a over 2, which really is 1/2 a, right? So I'm going to write that as 1/2 a, and that's y a plus 4 minus 2a. Now, I can combine them because 1a minus 1/2 a is what? 1/2 a, right? So that's x 1/2 a minus 2, which can also be written as x a over 2 minus 2. Okay? And then I can, either answer would be acceptable. And then I write my y's combining my a's. 1a minus 2a is negative 1a, so that's negative a plus 4. Y negative a plus 4, and this is my simplification, my solution. All right, so let's look at 83.3. Actually, let's go to 83.4. That's where I wanted to go next. 83.4. And it says to simplify xa raised to the b, ya raised to the b plus 2 over x to the negative a. All right, the first thing we want to do is eliminate parentheses. So we raise our powers to our powers. The rule says we multiply them. So x, a times b is ab. Now we have y, and it's a times b plus 2 over x to the negative a. All right, I'm going to move this to the numerator. It becomes x to the a. And I'm left with x, a, b. I'll write this next to this x, x, a. And then I have y. I have to distribute my a, so multiplying a times b and a times 2. So that's y to the ab plus 2a. Or I could leave it a times b plus 2. Now I combine my exponents by adding them. So I have x, a to the ab plus a, y, a, b plus 2a. And this is your solution. So remembering your exponent rules is imperative at this point. All right, thank you.